Now we're going to do an investigation that will allow us to discover the number E. So we have this person, Grace, who puts $1,000 in the bank that gives her 5% interest compounded annually. And we want to know, how much does she have after 1 year and how much does she have after 2 years? So we know that the initial value that Grace's investment will be $1,000. And then we need to figure out what B is, what the growth factor is. So we know that B is equal to 1 plus R, and R is equal to 0.05 because 5% interest as a decimal is 0.05. So 1 plus 0.05 is 1.05. So now let's evaluate G of 1 and G of 2. And we could do that by plugging in 1, multiplying 1,000 by 1.05 to the 1, which is just 1,000 multiplied by 1.05. So we know we're going to get 1,050 for G of 1. And then G of 2 is 1.05 squared multiplied by 1,000. So let's just go ahead and graph the function g to see what we get. So when I graph the function g, I see that after a year, Grace has $1,050, and after 2 years, Grace has $1,102.50. And I'll just write out some words here. $1,050 after 1 year, $1,102.50 after 2 years. So now we have this other person, Aliana, who puts $1,000 in the bank that gives her 5% annual interest compounded monthly. So because we have 5% annual interest compounded monthly, the annual interest is divided by 12. And there are going to be 12 times that we are compounding every single year. So what this looks like is A of t equals 1,000 multiplied by 1 plus, and then instead of 0.05 for R, we're going to have 0.05 divided by 12 because the annual interest is divided by 12 months in a year. And then, since every year we're compounding 12 times, we're going to have to the 12t. So this gives us a function that tells us the value of Aliana's investment after t years. And we can evaluate A of 1 and A of 2. So let's look at this graph, and I'm going to restrict it to only positive values of t, since time is positive. So here's the graph of Aliana's function, also starting at 1,000. Now let's look at the investment after 1 year and after 2 years. So after 1 year, the investment is $1,051.16. And after 2 years, the investment is $1,104.94. What are these numbers again? $1,051.16. And then this says $1,104.94. So 1,051.16 after 1 year, $1,104.94 after 2 years. So we can see that compounding monthly does allow us to make more money. Because if we compare after a year, we're doing a little bit better, and after 2 years, we're doing a little bit better. So the question is, how much better can we do? Because we didn't do that much better by compounding monthly, but perhaps if we compound more than that, we'll have a more significant improvement. That's a question that we can ask. So the next thing to figure out is, how do we write a function for the total money earned after t years when we invest some initial amount of money, P naught, so this is like the principal, the initial amount of money, at an interest rate R compounded n times per year. So let's break this down. We'll say A of t, the amount of money that we have at time t, is equal to P naught, which is the principal, the initial amount of the investment, multiplied by 1 plus the interest rate divided by n, which is the number of times that we're compounding, to the NT. So NT will be the total number of times we're compounding, because we multiply the number of times we're compounding in a year by the number of years. So this is a formula that gives us a way to calculate the value of the investment if we know the number of times we're compounding, the interest rate, and the number of years. So let's use this idea in the following way. Let's say you put $1 in the bank that gives you 100% interest compounded n times per year. And we want to know, how much do you have after 1 year? So this is going to be A of 1 is equal to, since we're figuring out what we have after a year, it's A of 1 equals 1, because we're starting with $1, multiplied by 1 plus, and because we have 100% interest as a decimal, R is equal to 1. So we have 1 over n to the n times 1, which is just n. So I'll write that out. Because t is 1, we just want to know after 1 year what do we have. Then we can just write to the n, to simplify this, I'll take this one off here and then just write it this way. This is just 1 plus 1 over n to the n. And a question we might have is, what happens to the amount in the bank as n increases? So if we are interested in what happens as n gets really, really big, we can look at a graph of y equals 1 plus 1 over n to the n. And we're going to do that right here. So let's look at a graph of y equals 1 plus 1 over n to the n. Oops. Just a moment. Oh, there we go. Great. So here's the graph. And it looks like it has some kind of horizontal asymptote, because if we zoom way out, we see that it appears to be leveling off. And it turns out that the horizontal asymptote of this function is y equals e. And e is the number 2.71828182846, etc. It's a real number that is irrational. It's similar to pi in this way. So here's a graph of y equals 1 plus 1 over n to the n. I'm going to label this. This is a graph of y equals 1 plus 1 over n to the n. And then this is the horizontal asymptote, y equals e. So the number e is defined as the limit of this expression as n goes to infinity. We're going to write that down here. So we have the limit, we're going to use x, as x goes to infinity of 1 plus 1 over x to the x equals e.